Okay. Finishing up with the introduction definitions. We're going to just use a CAS, computer algebra system. I'm going to be using Wolfram to construct direction fields. To plot the direction field, we're going to do two things first. Define a function in terms of x and y. The function of x and y is just what y prime equals. I'm also going to find another function r. Square root of 1 plus f squared. Then we're going to use the vector plot command. First component is 1, second component is f over r. We now need to choose a view on the window. So what are we going to let x go from? What are we going to let y go from? Let's start with -5. You can always adjust that as necessary. And then shift, enter. This is its default, so this is how it will look. There are options. For instance, one of the options I use is vector scaling. I set it to 0.03, not status. Now that can affect it. Just make them smaller. I'm also going to set vector points to be fine. I also don't like them being colored. That color's representing big magnitude. Because each vector that's shown on there is not to scale. So I'm pretty sure the color coding is signifying its magnitude. I did black. What if I do same effect? That's fine. But I don't like that it's framed. I'm going to turn the frame off. but I'm also going to have to, at the same time, turn the axes on. I just personally prefer that. And if you wanted to, you can also label the axes and change the style. So I can, for instance, make the axis style bold to make them stand out a bit more. You can label them. Oh, that looks pretty good. That would be our direction field for this first order differential equation. Now what I'm going to do is I want to convert this. Right, so if I hit settings, convert to, right, so see the little gear icon there, settings, convert to image. Well, I guess it did. Yeah, it did, okay. So now I can just copy and paste it as an image, which is the best way to copy and paste. Otherwise, some funky things might happen. I can just paste it as a picture, change the size, change the size to whatever I want. That looks good. There's our direction field. And I think for the group assignment, you have to do some direction fields. So that's how you get them into your document. Apparently I have number 17 twice, so I'll fix those numberings. No, that's it. That's the direction field. Really easy. Once we get into solving the first order equations, we can also plot on the direction field what are known as the interval curves, or your solution curves, or isoclines. I think they're also sometimes referred to as. If I'm not mistaken, this can only be done for first order. The direction fields. You can still do interval curves for higher order, which is a little more complicated, but direction fields, I believe, are only first order. I've never seen them for anything higher. Copy and paste. And if I wasn't going to upload this document, I'd just change my f of x, y, and then re-execute it. It's now x squared plus y squared minus whatever it was, right? That's all I have to change. I'm not really going to change any of the settings. And then just shift enter, and there's the direction. Or if you wanted to, you could try and change some of these functions. If you want to change the viewing window, let's do that. What happens if I go out? I think it's going to be interesting, to be honest. It doesn't like it.
You forgot a -10 for long.
Ah. I don't know, I deleted that negative. It just goes out a little bit more. It doesn't look as interesting. So, undo, undo, undo. Go back to the original. The next one was y prime equals x over 2. And the fourth one, five y primes, y minus 1. That's all there is to plotting direction fields. I'm 99% confident that the TI Inspire cannot do it. I don't think you can plot vectors. I could be wrong, might be able to, but I don't think it can. Also, as a note on terminology, notice I'm referring to all those as plots, not graphs. That's not a graph. Even when you sketch the graph of a function, that's not actually a graph. It's a plot. Graphs are something different in mathematics. Yet every textbook insists on using a graph. Questions on direction fields?
This would be posted
The 5, yeah. I'll post it after class. Slides are already up there and updated.
What's the R function?
Square root of 1 plus f squared.
How does that like affect the plot?
That is normalizing. Essentially. I'm making sure that it has a length of 1. It's just to make it look nice. It's just the instructions that we have to use to do the direction fields.
So does it require?
Yes. Right, so that is how you do direction fields on Mathematica. Maybe different on a different graphing software. But for Wolfram, this is how you have to do it. And again, all these options are not mandatory. You could have just stopped with what's not highlighted and it would have been fine. And you can play around with it too. If I come down the vector color function, because there's a bunch of options. Actually, it's not coming out now. You should see like a list of all these. There's all cherry tones or something. I'm hoping there's cherry blossom. Coffee tones. Okay, I'll just do coffee tones. You know, coffee. The lifeblood of every grad student. Specifically Irish coffee. So again, you can have some fun with it. Anything else? Wolfram is a coding language, so it is going to take some getting used to. If you're not familiar with it, it may take you a little bit longer, but then once you learn the language, it's like anything else. It's very simple. That's why I do recommend you take care of the document, take advantage of the documentation center as well that I provided. You can just search everything up. Documentation center back when I was in school was not online, it was a textbook. Textbook, 5,000 pages. It was that big. And this thing was a weapon. I used the bench press too. That sucker was heavy. It sucked. And it didn't have half these features. It's really changed, come a long way since then. I think that's why they don't do the book anymore. It'd probably be closer to 50,000 pages right now. But take advantage of that. Also, Google. Stock Exchange, I find, is really good with helping to do things on Mathematica. Right, and I did post all the fields on the slides so that you know what you get. Any questions on anything that we've done with the definitions, the terminology? We're going to start solving at 2 o'clock. We look at our first type of differential equation, a linear differential equation. And we'll learn how to solve those. Then we'll do the nonlinear stuff. I actually made sure there were the right ones this time. 20, oh, perfect. Got half an hour to do this, running close to 150, 10-minute break, 2 o'clock, we'll then start with solving linear differential equations. Let's go ahead now, pause.
Oh, yeah.
So get into your groups.
selected.
Yeah, so stop selecting on the first day.
Oh,
so this is your first time.
Right, yeah, exactly, I apologize. I didn't look straight.
So, I don't know if you saw the. Stop this recording. I don't know if you saw the recordings that I posted.
I saw the first one.
First order linear equations. Are familiar with what linear equation is. First order, just a1 of x times dy dx plus a naught of x times y equals some function g of x. We call that linear. Standard form, dy dx plus p of x times y equals some function of x. If f of x is identically 0, then we say that the equation, the linear equation, is homogeneous. And obviously, if f of x is not identically 0, then it's non-homogeneous. I'll let you read through a lot of this. This is just kind of going into how we're doing relative solutions. This is the actual method. You first need to put it into standard form. Then you find your simple antiderivative of p of x. We'll call that simple antiderivative little p of x. Your integrating factor, mu, is e to the little p. Multiply through by mu. That will automatically yield d dx of e to the px, your mu, times y is equal to mu times f. Now just integrate both sides. Then divide by mu, and that's your solution. That's for the general solution. Obviously, then if you have initial conditions, find your constancy using those initial conditions. And then this slide just goes into two special types of functions. The error function and your complementary error function. ERF and ERFC, I guess we'll call it. These will come up because there may be times, I don't know how often we encounter in this class, but when you have to solve linear and you integrate, you don't get an analytical antiderivative. In which case you'd have to leave your solution in integral form. But if you get one of these, you can write it in terms of your error functions. So let's go about solving. Y prime minus 3y equals 6. First thing you do, we only have one method right now. When you're given the first order differential equation, you first want to decide which form is it. We're going to be studying several forms. Well, this is clearly linear. Second, check, is it in standard form? Yes. coefficient of y prime is 1. So it's standard. What is the coefficient of y? So you find its antiderivative. That one's easy to find. What is it? What is it?
3x. Negative 3x, sorry.
Your integrating factor is e to the negative 3x. Multiply through by it. What you'll notice, now this left-hand side is a product rule. And first times derivative of the second plus second times derivative of the first. It's the derivative of that function. We now anti-differentiate both sides. What is the antiderivative of a derivative?
The original function.
Mm-hmm. It's the function you're differentiating. They undo each other. As long as it's with respect to the same independent variable. What is the antiderivative of 6e to the negative 3x? We could use a calculator, but we're going to test our knowledge here.
Is it negative 2e to the negative 3x?
You sound very confident.
It's because I'm not.
Let's gauge how confident you really are. You're in Vegas and you're wagering your grade on it. How much would you put down? My final grade points are obviously 0 to 100, so that's what you're wagering, 0 to 100 points. How much would you put down on that?
How do you answer that question? Not a lot.
Well, that's not good. That's a shame. House always wins, because that's correct. Moral of the story, trust your gut.
So it's okay, I won't say it.
I'll give it to you. You're not entirely correct. There's something missing,
Why? Oh.
but close enough. Close enough for government work. We want to isolate y, just multiply both sides by e to the 3x. And either negative 2 plus ce to the 3x or ce to the 3x minus 2. And we don't have initial conditions, so we can't find C.
So, I have a question about why does e to the negative 3xy equal negative 2 e to the 3x?
Because all we do is anti-differentiate both sides, right? You have two functions that are equal, their antiderivatives are also equal to a constant. In other words, what we're saying is, we're saying the derivative here of e to the negative 3xy equals 6e to the negative 3x. So what's the original function? The antiderivative, that's.
Gotcha. And then, but we can't use that because it has a line in it, so then we have to,
What do you mean you can't use this as a y?
we want the solution for,
Right,
so
so
not
you,
everything in terms of x and it's.
not necessarily. In the case of linear, you will be able to. But there will be times where you can't get,
Why do you, yeah, for this problem?
you can't get an explicit solution all the time. But again, for linear functions, that will never happen. You can always get explicit functions for linear. And we'll deal with the implicit solutions starting next week. Is that linear? Is it in standard form? So we can just proceed. What is the coefficient for y? That is our capital P. What is it? What's that antiderivative? Simple antiderivative.
Negative x squared.
There's your integrating factor. E to the negative x squared. Multiply through, and a lot of the time I just skip that intermediate step and jump right to
So for the mass, we're always going to be sending it to e to the power.
that. That's your integrating factor. So first you're going to find the simple antiderivative of capital P.
Mhm.
E to that power is your integrating factor. And e to the negative x squared y would have to be that antiderivative. How would you evaluate that antiderivative?
Integration by parts?
What's your u?
Oh, never mind.
Not for integration by parts.
No, stating x.
Then your dv would be e to the negative x squared dx. What's that antiderivative? There's none.
So just be separate.
This is just plain, simple u substitution. Very first change of variable technique you learned.
That's all I was asking.
What is your u?
Yeah, negative x
Your du?
is negative 2x, yes.
So it's negative a half, then it's just the antiderivative of e to the u, which is e to the u. Now multiply through by an e to the x squared. C e to the x squared minus a half.
So,
There's your solution.
so why do you multiply through?
So you can isolate y. Right, because e to the negative x squared times y equals that. So what does y equal? You divide by e to the negative x squared, which is the same as multiplying by e to the x squared.
Listen,
These are standard formats. Is that linear? Yes. Is it in standard form? Yes. What is big P? Or is our P of X? What's that antiderivative?
We're at ln
That?
absolute value of x.
I can simplify that.
The power of 4. That's the power.
Why did I drop the absolute value?
Because it's no longer absolute. I agree. It's no longer absolute with the exponent.
Not necessarily.
It'll always be positive,
Y will always be positive.
because it's, extra short, so, if you multiply a positive, it'll be positive, negative, also, it'll be positive.
Why? Because the exponent's even. So I can just get rid of the absolute value. If it was cubed, I couldn't. And so mu is e to that. How does that simplify? Because that does simplify. It's just x to the 4th. Exponential and logarithmic are inverse functions. That means that the derivative of x to the 4th times y equals x to the 4th times x to the 4th, which is what? X to the 8th. Oh, good, we're remembering our algebra so far. That's good. What's that antiderivative? Is that it? Plus some arbitrary constant. Now divide by x to the fourth. You can either write as x to the minus fourth or c over x to the fourth, doesn't matter. And if you really wanted to, you could also write that cx to the minus fourth out in front. Again, it doesn't matter. Right, so far all of these have been families of solutions. Right, because these are all solutions for any constant c. Those would be your integral curves, by the way. For all the different values of c, each one gives you an integral curve. Which typically you would then plot on top of your direction field. Now, it's actually a bit of a pain to plot integral curves. There's a way to do it mathematically, but it's still a pain. You have to involve the table command and choose different values for c. Well, you can't do all of them because that's an infinite number and you can't handle it. So you have to decide, okay, what range of values I want c to be, how do I want c to change for each curve. It's a nightmare. I was wondering how long it would take before we got to symmetry. I don't think I've warned you yet. I love trig. That's your warning. Is that linear? Is it standard form?
No, it's not.
It's not? What does it mean to be in standard form? Coefficient of y prime is 1. It is standard. What is p of x? Ooh, this is going to be the toughest antiderivative we did. What's an antiderivative? It's just x.
Let's see, right?
Technically plus c, but we only want the simple antiderivative for integrating factor. Right. Mu is then e to the x. This means the derivative of e to the x times y equals e to the x times sine of x. E to the x times y would be that antiderivative, and if I really wanted to, I could just multiply by e to the minus x right now. And we could write that y e to the negative x times that antiderivative. Doesn't matter when you do it. How do you do that antiderivative?
Integration of parts.
That is integration by parts. What's the easiest way of doing it? easiest way to do it. We're gonna pretend that calculators haven't been invented yet. We'll go by hand. Like we're back in Calc 2. Well, on test or quiz, I don't care. I'm not testing if you can take integrals at this point. If you can't take an integral, you shouldn't be in this class. But again, good practice. We'll do it by hand. So we'll do like a little side note. It doesn't matter what you choose for your U and your dV. I typically pick U to be the trig. Because anti-differentiating e to the x is usually easier than anti-differentiating a trig function. What's du?
E to the x dx.
Just cosine? And cosine of x dx. Right, remember your u, you pick, your dv is what remains. Then what is v? Just e to the x. And what was the integration by parts formula?
uv minus m to the equal v.
Uh-oh. What's that antiderivative? What do you have to use?
Integration by parts.
By parts again. To avoid confusion, you shouldn't use the same variables. You could just do u sub 1 and v sub 1. That's not really fun. I use the Greek letters that most closely resemble u and v. Mu? What should mu be in this case? It has to be cosine. If you choose it to be e, you're going to get a tautology statement. You'll get like 0 equals 0. Which, while true, is not helpful. Which means that d, nu, and u. What is d mu? And what is nu? That's not good. Oh, but wait, what was the original antiderivative? Now algebraically solve for it. You distribute that negative through, which means you add that I to both sides, you get 2 times I equals something, divide by 2. I'm going to avoid all that work and just say that that's the end. Or back up the e to the x. Half e to the x times sine x minus cosine x. And there it is. That would be our solution, our general solution. Good. So actually a little story about the Greek letters here. Probably gonna bring back some trauma. Back in 2020, all the variants they used, you're aware of the Greek letters. They went from what, lambda to Omicron, I believe. I think the last variant they named was the Omicron. They actually skipped 2 Greek letters. They skipped C, XI, and nu, and U. Nu for obvious reasons. It'd be called the nu variant. They didn't want it to sound like NEW. Because C is a little more political. President of China, Xi Jinping, XI. They didn't want to confuse that either. So they skipped those 2 and went to Omicron. And I never knew Omicron was a Greek letter, so that actually did teach me something. Omicron's just an O. Funny enough. So there's your little Jeopardy trivia for the day.
How did you get I there?
I just said the equals I. So I have to rewrite the antiderivative.
Okay, but how did you get that part? I lost you there.
I algebraically solved for it.
Oh, okay.
This here is I.
Oh,
Right? I equals this. Add to both sides, divide by 2.
gotcha.
Also, that antiderivative should be one of the classic examples from Calc 2 for integration by parts. It's between that one and e to the x cosine of x. You can use either one interchangeably to get the point across. Well, look, an initial value problem. Solving initial value problems. First thing you want to do is just find the general solution. So for now, we ignore the condition. Just look at the equation. Is it linear? Linear in what? What's the dependent variable? Yeah. Is it in standard form? Yes. What is P of X?
Maybe that's.
What's that antiderivative?
over two.
Makes our integrating factor e to the negative x squared over 2. And if you multiply through, we get d dx e to the negative x squared over 2 times z equals negative x e to the negative x squared over 2. What's an antiderivative?
Sorry, what was the question?
What is that antiderivative?
X e to the negative x squared over 2 over 2?
You'd have to add 1 to that, right? So
We would have over negative e to the negative x squared over 2.
It's just e to the negative x squared over 2. How'd you get it?
Use substitution.
Let u be negative x squared over 2. du is negative x dx. So look, you have negative x dx. Plus your constant. General solution, z of x equals one plus c e to the negative x squared over 2, right? That is the general solution. But now we're given the initial condition. Second step of solving an IDP, use the initial condition to find your constant, or constants if you're dealing with higher order. Now we use the initial conditions, z of 0 equals negative 4. Right, so z of 0, what's e to the 0? Right, so z of the 0 being 1 plus c, that has to equal negative 4. So what is c? That is our solution. So out of the family of curves, that's the one solution we're looking for. Which is why, generally speaking, a lot of the time, I skip solving IVPs. Because at that point, it's just algebra. The more important part is finding your general solution. That's the most important part. Is that linear? What's the dependent? What's the dependent? Q. What is the independent? Is that in standard form? What's P of t? What is it?
2/10 + 2t.
What's that antiderivative?
Read 2 ln 10. No, because you separate them.
You're close. You're going to say this, right?
Yeah.
That's very close. Take that derivative. Do you get 2/10 + 2t? What do you get?
I'll give you 4 over.
Which means that can't be the right antiderivative.
Yeah.
That is. You have to use u sub first. U is 10 + 2t, what's du? 2 dt. So that 2 just disappears. That means our integrating factor is that which simplifies to what? Close. It's not 10 + 2t. Am I taking the log of 10 + 2t? Absolute value of 10 + 2t. Here's where I'm going to make an assumption. It should be a fairly safe assumption with my background. T represents time. What do we know about time?
Can't be 0, that's negative.
Well, it can be 0.
Yeah, it can't be negative.
Has to be non-negative. 10 + 2t, is that negative whenever t is non-negative? Ten plus 2t would always be positive. So I can just drop the absolute values. Under the assumption that t itself is actually representing time. In fact, I could drop it anytime t is greater than -5. Greater than or equal to. No, it has to be greater than -5. So you can't take log of 0. So we're gonna say that this is the integrating factor. And I'll write that is our assumption. In fact, when I saw this, the first thing I thought of was Q is charge. That's what capital Q represents in physics, charge. Which means dQ, that's actually current. This is an equation to solve for current in a circuit, a specific type of circuit. I think this is just an LC circuit. Because it's RLC, that's a second order, I believe. So what we get the derivative of that would equal 4 times 10 plus 2t. Which I will distribute out. 40 plus 8t. That is a simple antiderivative to do, right? What's that antiderivative?
Squared over squared.
Q of t would then be which can be simplified because there's a common factor too. Now, I technically made an error. It's more of a syntax error than a logical error. What's the error?
C over 10 plus 2t. It should stay that way. Or no?
Doesn't have to. But it does have to do with that C. That should technically be C sub 1. It's a different C. C sub 1 will be C over 2. Right, but it's a constant divided by 2, still a constant. So, in terms of syntax, that shouldn't just be C, it should be like C sub 1. I'm too lazy. So I'm going to do C. Just be advised that is a different C. It's a different constant now. Because I factored the 2 out from it. Now apply the initial condition, which technically isn't really an initial condition. Be more of a boundary condition. Right, initial would be Q of 0. But first order doesn't matter. Q of 2, plug in 2. 20 times 2 is 40, right? 2 squared?
4.
4 times 2 plus 40. Five plus 2. And that had to equal 100, right? Self-see. So let's see.
632.
6 what? That would be our particular solution. Again, this is all under the assumption that t is time. If we can't make that assumption, you could still do this. You just have to specifically specify the interval that this solution is valid on. In this case, it would be t greater than -5. You'd have a different solution if t was less than -5. And it's not defined at -5. Is that linear? Yes, it is. Is it in standard form? What is the dependent variable? Big T. Independent is little t. What's P of T? It's 0, which means the integrating factor, there isn't one.
Why is it 0 in the variable there? K?
Is that K times big T? Which means that's just part of a constant. But technically there's an integrating factor. The integrating factor would be 0, which is 1. That doesn't do anything. So what we're going to do is write it that way. do that. What is that antiderivative? What is it?
Uh, oh,
Did you pull out the K first? Or did you distribute it first?
You tell me.
I would pull it out. Mm,
That's what I would do too.
100t minus t squared over 2.
Is that it?
Plus c.
I'm gonna write on the outside. Or factor out a 2t as well. Doesn't matter. You don't have to. And now the solution. In this case, big T most likely represents temperature.
So what is that notation d big T over d little t?
Just derivative of temperature with respect to time.
Okay.
How is temperature changing with time?
Okay.
It occurs a lot in thermo. Of course, in thermos, not that simple, sadly. But that would be a topic for a much more advanced physics class. You know, do you think thermochemistry is bad? Or thermoengineering is bad? It's even worse in physics. Because it's all probabilistic. It's called stat mech, statistical mechanics. It's awful. They tell physics people to take that in your very last semester so it does not appear on the transcript when you apply to grad school. They're going to fail it. That's what they say. I got a B. Don't know how. I'm not complaining. I got a B. I'm happy with it. No, I want to say we've never gotten 4.0s in undergrad because I never would have gotten an A in stat mech, but I could have gotten an A in every other class. I actually cared and tried. And except for stat mech, that's the one class I never would have gotten an A. I'm just happy to get a B. Why were you able to actually factor out that K? Because I told you an arbitrary constant, right? If it wasn't, you would not be able to factor out that K. Good. I still have a little bit of time, so I think I will go back into some trivia. You are forbidden from answering. What is the second law of motion?
Second law. Any force that's an equal and opposite.
That's the third. That's the third law.
It's just the conservation of electrons.
That's something different. Conservation rate is something completely different. This you can answer.
Not equal value.
Technically speaking, some of the forces is mass times acceleration. But we'll just stick with the more simple F equals ma. Was Newton right? Is force mass times acceleration?
And that's the integral of the equation.
Another way of writing is force is changing momentum. Momentum is mass times velocity. So if you take the derivative of that, question is that n times a? What's derivative of velocity?
Acceleration.
Acceleration, right? What are you told about mass?
Constant.
So you say that derivative is ma?
Let's see.
No, not plus c. That's only when you differentiate. Yeah, you made a fatal flaw. You actually assumed mass was constant. It's not. Mass is not actually constant. Mass is a function of speed. Faster you move, the more mass you gain. And speed is a function of time, which means mass is a function of time. So why do we use Newton's second law? If it's not actually correct.
Oversimplification.
But why?
To make things constant, I guess, like just to come.
There is a reason why Newton's law is valid. It's valid in certain circumstances.
The change in mass is so small that it just touch it.
When does that occur?
What occurred?
When the change in mass is negligible. Under what conditions would that occur?
Faster than.
When you move much, much slower than the speed of light. Which for everyday scenarios happens. Right. Once you start moving closer to the speed of light, now you can't ignore the change in mass. It's also why there's only one known particle that can actually travel the speed of light, photon. It's the only massless particle that we know of. Every other particle has some kind of mass. Anything with mass can never actually truly travel the speed of light. It would then gain infinite mass. Because E equals mc squared. C is constant. The faster you move, the more energy you gain. If C is fixed, that means your mass would have to increase. Time is also not constant. Time is also a function of speed. Actually, it's a function of two things. It's a function of speed. It's also a function of how close you are to a gravitational force and the strength of that gravitational force. That's all relativity. sadly I had to study. My branch was cosmology, which means, yeah, general to be kind of important. Sadly, so is quantum. Which means sadly so is string theory. Yeah, Newton's actually wrong. He was wrong a lot, by the way. He also has a universal or a law of gravity, which is incorrect as well. His law of gravity is wrong as well. You have to use relativity to get the right law of gravity. And that's where Einstein's field equations come in. I mean, that's all true. It's never going to really matter to you unless you take advanced physics. Questions on linear functions? Solving. Here's what's going to happen next class. The first, let's say, 30 minutes will be the worksheet for this stuff. I don't want to start it today and then I can pick it up again on Tuesday. So Tuesday, we'll just do the first 30 minutes, be the worksheet. We'll do a 5-minute break. And then the rest of the class will be the next topic. You're going to have 2 worksheets next class, that means. So we'll have a full 100 minutes at the end of class. Your first quiz will also post after next class. So next Tuesday after class, the first quiz posts. And it will be due before Thursday's class.
We can quiz on our own, no.
Yeah, that is on your own, and it's online. It's delivered through Blackboard. You should actually be able to see it, you just can't open it yet.
Yeah. Is that the same for the tests as well?
Tests are in class.
Okay.
So the test will be in class. And your first group assignment is also posted. That, I believe, yeah, that has a due date of June 17th, right? So that'll be due June 17th. And continue to work on your homework journal. Second assignment is posted on the week 2 as well. That's all the linear stuff. All of those, remember, that will be collected the day of the first exam, which is June 24th. Amazing, just like that, it's the weekend. Have a good weekend, I'll see you later. Yes.
Yeah.